Okay, we're going to look at section 9.3, geometric sequences and series. All right, last time we did the arithmetic sequences and the partial sums. So this one's a little bit different. Geometric sequence is when you have a ratio that gets you to consecutive terms, which means basically you're multiplying or dividing to get to the next term. So that's the big tip. So if you've got 2, 4, and then it would be like 8, 16, 32, 64, you can see that you're multiplying by 2 every time. This is the only one where it is possible for your sign to alternate. So you could go positive, negative, positive, negative, positive, negative. So if I was multiplying by -2 each time, you could end up with the alternation of the signs. That cannot happen in the arithmetic sequences. But they're going to call it a common ratio. So let's kind of get to looking at how this works. Here's just some examples of what geometric sequences look like. When you start looking at this first one, that's the example I just gave you. To get from term to term, you are multiplying by 2. Now, what you're going to run into is we're going to have the formula for the explicit form for a geometric sequence. So a sub n is equal to a sub 1 times r to the n minus 1. All right, so you could easily produce your explicit formula by looking at that sequence. So a sub n is equal to first term, and then your ratio, which is what are you multiplying by each time, and then it is always raised to n minus 2. So you can create your explicit form rather simply, and most of the time by inspection you can just tell what you're doing, and there's your explicit form right there. They just put the n on the inside. This one is the same way down here at the bottom. Your first term is a -1/3. That's your a sub 1, and then every time they're multiplying by a -1/3. There you go. So let's see if we can conjure this up ourselves. So there again, that's the explicit form I was telling you about, where r is your common ratio and a sub 1 is your first term. So make sure you know what each portion is referring to. Okay, now to start off with, first example says write the first 5 terms of the geometric sequence. So it's important that you determine what kind of sequence you have. And then they stipulate that the first term is 3 and the ratio is 2. So use the explicit form that you just saw to the n minus 1 and put your information in. You got 3, and then you're going to have 2 to the n minus 1. So now you have your a sub n formula. You can generate your first 5 terms if you want to. Now, quite honestly, you can use your calculator. You can go to y equals, and you can type that in. Just don't use an n, use an x. And then go to the table, and you can get your terms rather quickly. Otherwise, just start putting in numbers. So you got 3 to the 2 to the 0. Well, let me take this out so I got room to write. That's going to be 3 times 1 is 3. And then you're just going to keep going. Now soon you're going to develop a pattern here. So you got 2 to the first. So I do believe that's 6. You got a sub 3. So 3 minus 1, so you got 3. And then 2 to the second, well, 3, and then that's going to be times 4 is 12. So you should be able to figure out what's going on every time this thing is multiplying times 2. So whether you filled in the rest of the information or not, you can go through here. 12 times 2 is 24. 24 times 2 is 48. So you could complete your sequence with what it requested, whether or not you put the the rest of the information in or not. Okay. Example 3, it says finding a term of geometric sequence. So find the 15th term, and all they tell you is that the first term is 20, and the common ratio is 1.05. Okay, well the only thing you have is the formula that you just learned. So you got to use it. So come in here and put your 20 in. R goes into place, or 1.05 goes in place of R. And you now have your formula. It says find the 15th term. Okay, well if you did that, 15's down there. You're just going to put this in here. If you put 15 there, now you're raising it to the 14th power. If you type all that in your calculator, you get 39.6. It actually is a nice long decimal, and you just have to round it. It rounds nicely to 39.6. So all you're doing is substituting 15 for n, and when you put 15 for n right here, 15 minus 1 generates as 14. Okay, keep going. Example 4, finding a term of a geometric sequence. This one asks for the 12th term, so that's what we're looking for. And then it just gives you a portion of the sequence. Well, you've got to look at it and come up with the fact, oh, it starts with 5. And then you're supposed to figure out what your ratio is. Well, remember, your ratio is built on like the second one divided by the first one. Well, there you go. Ratio is 3. So start again, same formula. What is this? A sub 1, R to the n minus 1. Plug in all your goody. 5, 3 to the n minus 1. Well, now they want a sub 12. Okay. I'll come over here. If you put 12 right there, that's going to be 11. If you type all that in, it gives you a nice big number. 885,735. Gets really big, really fast. Okay, next part. It goes to finding a term in a geometric sequence. Same type stuff that we just did. It says the 4th term is 125. And it stipulates that the 10th term is 125 over 64. So that's a little nasty. You're just going to have to hang on, bear with it through the algebra. It wants to know what the 14th term is. So you're assuming that the terms of the sequence are all positive now, so we're not alternating. For right now, let me just get rid of all of this. That right there is something nice to remember. These are just little hints that I had typed up earlier. So let me block these off. So you got the 10th term is related to the 4th by this equation right here. So they gave you this. So remember, to get to the 10th term, you have a sub 4 times your ratio 6 times. Now, that's a formula that you might want to put in your notes. It's not on your yellow sheet, so you might want to put it there. A sub n equals a sub m times r to the n minus m. And we're going to stipulate that n is greater than m. Okay, so that is how you can find the common ratio. We had a similar one for finding the common difference last time. There we go. So let's come back here and do this. If we did that, a sub 10 is this crazy fraction right there. A sub 4 is 125, r to the 6th. So if you come in and you divide by 125, that's the same thing as multiplying by 1 over 125. They cancel, gives you r to the 6th. These cancel, but you got 1 over 64. You've got to do the 6th root. So the question is, what number times itself 6 times gives you a 64? Now you know 1 does that, but in the bottom it's going to be a 2. So your common ratio is 1/2. And then you've got to come down here and keep on going. I'm going to use a little different setup than this one down here. You can do what we've been doing, so you don't have to kind of like start from scratch. If you use your regular old formula, you can use your, well, we need to figure out a sub 1. Your R is 1/2. You can use any of these pieces that we've done so far. I just use this top one, a sub 4. If you put a sub 4 right there, okay, then that means I'm going to have 4 minus 1. And I'm getting the 4 from the fact that I put a 4 there, so I'm going to put a 4 here. So a sub 4, we said, was 125. I don't know a sub 1, that's what I'm looking for. So I got 1/2 there. 4 minus 1 is 3. Okay, let's speed this up so we can get some space so we can write. Okay, whoa, 125 equals a sub 1 times, and if you cube that, 1 cubed is 1, 2 cubed is 8. Now I got to get rid of 1/8 and multiply by 8 on both sides. So a sub 1 is, I do believe that is 1,000. It is. So go back to our original. Our original was a sub n equals a sub 1 times r to the n minus 1. Now I know that 1,000 goes here, 1/2 goes there. It asked me for a sub 14. If that's the case, come in here and if you put 14 there, you get 13. If you type all that in your calculator and hit math, enter, enter, you get this lovely little fraction. Now I realize the way I worked it might have been longer than what you might see represented somewhere else, but I was trying to keep it from being as confusing. That may not have succeeded, but I was trying to keep you using the same format and the same procedure you've been doing in the other problems. So whether or not that worked, we'll see. I will finish this up in the next video, so see you then.